theoretically you can participate remotely in the same room. But you will have to travel across the room in order to ask a question at the mic. So once again, good morning. Welcome to the SDN Research Group here at IETF 95 series. So please pay close attention to the note well. This is the existing note well, not the new note well that hasn't been formally adopted yet. Everyone should be aware of the IPR policy. So the usual housekeeping and administrativa. We have the proceedings online. All of the slides except the Nemo slides have been uploaded. So if Bert is in the room, bad Bert, please email us the slides as soon as possible. Otherwise, you'll have to bring them on a USB when you come up to present. So we do have a minute taker. I believe Will kindly volunteered on the mailing list. We are looking for a JavaScribe though, so it would be very beneficial for the research group at least to have a JavaScribe if we have remote participants. So if we can have a volunteer for a JavaScribe, it would be much appreciated. So the JavaScriber is the lesser of two evils. The minute taker usually has their work cut out, especially when we have lots of questions at the mic. So don't be shy. This is an opportunity to finally use your Pigeon client. No one, we can't convince anyone to be a JavaScribe. I'm going to have to start naming people. Ah, fantastic. Thank you, Tim. Oh, right. So Tim will be our JavaScribe. And already, actually, we've got 12 people in the meeting room, so that's good. It's going to be good. We try and pay close attention to any questions, especially on the open mic sessions. So here is our agenda. It's been published now for a couple of weeks. There has been some slight amendments. We did have sort of an overview of SUPER, which is a IETF working group. Considering we've got this special discussion today on intent and policy and SDN across SDOs, so we wanted to kind of have someone from SUPER just sort of present some of the work that's happening in that particular working group, but we decided actually that we would just focus on intent and not bringing the SUPER discussion at this point anyway. If you are interested in SUPER, Simplified Use Policy Abstraction, then the working group meets on Friday. We also had a request this morning, actually. Okay, thanks, Bert. I think we have his slides now. We had a request this morning, actually, for a research group presentation slot on a fairly new internet draft. This is the open orchestrator. So if we have time, and we should have time on the agenda, we can squeeze that in at the end of the agenda. So any additional agenda bashing? Going once, twice, 3 times. Okay. So Carlos, I think you're up. Sorry, Carlos, just before you start, the Meet Echo is not currently on. Do we have support for Meet Echo? Should we just press the power button and see what happens? Okay, well, we'll try to address the Meet Echo situation, but currently I don't think we've got connectivity to the server. No, okay, well, we'll try to sort this out sort of concurrently. Carlos, if you'd like to begin.
Thanks. Can you hear me? Yes. So I'm Carlos Bernardos from UC3M. I'm going to present a short update of the status of this draft. So before, just a brief history summary. So this draft was an individual submission until Buenos Aires, was adopted after Yokohama, and we presented this three times as individual submission in Toronto, Dallas, and then Yokohama. We received a lot of feedback and support on the mailing list. So thanks for supporting the document and providing comments. And next, basically, I will just quickly remind or provide an overview of what is the draft about, and then I will go through all the comments that we have received and how we plan to address those comments in the next revision. So the key concept of the document is how to separate the control function associated to the service and the transport. So basically, we're proposing to split into two different strata, the service stratum and the transport stratum. And then within each of these stratum, we of course have the three control, management, and resource planes. So basically, that's the main concept that is in the draft, this separation, and how to then provide the tight collaboration between the different stratum in order to achieve the efficient service provision. So this is basically what we have been presenting and what is in the draft in a very short summary, and this is the picture, high-level picture of this separation. You can see here that we have at the top the service stratum with the resource plane and the management and control plane. And then we have the transport stratum below with the resource plane and the management and control plane. And in the draft, we have some use cases supporting this, some motivation supporting this, how to deploy this, because there are different deployment approaches having this architecture in mind. And the idea is to keep on evolving this document, putting more details on how to actually have this abstraction here and how this interface will look like, and the architecture, provide more details about the architecture. So that's the summary of what is the document about, and then I'm gonna go through all the comments that we have received and then try to have some discussion on how to address those that are not basically easy to address, and then also ask you for some input on these comments. So I'm putting them in no particular order. So first, we received some editorial and clarification comments from Gabriel Lopez from University of Murcia. This has been already addressed in the interim version that we have, 01, that will be published, uploaded after Buenos Aires, and also considering the feedback of this meeting. Then we have also some comments by Gert on considering also some work that has been done in the CCMP working group. So we will address that in 01. So no major difficulty in addressing these comments. Thanks for them. Then we receive also some comments on Gino, on how to address challenges for implementing this different control action between the two stratum. So we will address this at least partially in 01. So maybe some of these things will not be completely addressed in version 01. One comment that he mentioned and that other people mentioned as well, as we will see later, is we should try to enforce or highlight more, emphasize the relationship with other working groups, research groups, and even SDOs of this work. So this is something that we will try to improve already in 01. But as we will see later, we would like to ask you as research group to also help us in identifying any relation that we may be missing. And please send us an email on the mailing list to include that, to ensure that this is included in the draft. He also mentioned that we should explore different options for using the same architecture pattern recursively across the different layers. So this is already partially addressed in version 0.0, but we will try to improve that in 0.1. Then we also received some comments from Ramon on that the need of developing further the multi-domain aspects with emphasis on different models, different deployment models. We already have something on multi-domain in version 0.0 and something on these different deployment approaches, but we will try to improve that in version 0.1. And here again, we have this comment that this has been done by different people on improving the alignment and the relationship with other similar unrelated initiatives. So this will be improved in 0.1. Then Christian mentioned that we should also look at this work that is being done in Sdnrg. So we will do that and address that in the next revision. And here we have also a comment that other people made that is about the use cases. So we have a use cases section in the document. We have a couple of use cases there, but people mentioned that we should try to improve that section. And this is one of the things that, of course, we will try to improve in the next revision, but we would like to ask you also for feedback. If you have any use case that you think is relevant to be included that has relation with the layer architecture, please comment on the mailing list and we will be happy to include that in the document. Another comment, this is from Ali, that has been also made by several people, is on the motivation for this architecture. We have some motivation section, but the people feel that we need to improve a bit this motivation. So this is something that we will also address in 0.1. Then, progressing, we have also received comments from Bartosz. Again, improving the motivation and complete the use cases. So we have already discussed this comment. And the same about including links or improving the relation with other working groups, SDOs, research groups. So this is something that we will try to do in the next revision. Same comment here from Maria on the motivation. So as you see, this is something that people feel that we need to improve. So we will try to do so. And then this, I think, almost the last one, but not the last one yet. Comments from improving the section on deployment, not only on the use cases, also this is also mentioned. So we will try to improve that section on how to deploy the architecture. Again, this is something that you have comment, feedback, input, that will be very, very welcome. Then we received some comments from Jacek. One is actually a question that we have for discussion. I will basically make the question here, but we should discuss on the mailing list. He's proposing to split architecture into 3 stratums, not only 2. So he's proposing to put the resource as a stratum instead of having resource plane in the 2 stratum that we have. So this is a question for the research group. What do you think about that? I personally feel that it's better as it is today, but of course, this is a research group document now, so it's up to the working group, to the research group, sorry, to decide. So please comment on this particular point on the mailing list. And he also mentioned about the motivation and the use cases, so this is something that we have already gone through. Then Evangelos also provided some comments. One first comment was about kind of trying to merge or just oppose the figure from the RC on the terminology and the figure in the draft. So this is basically the figure 1 in RC 7426 and this figure 1 in the draft. So he proposed to kind of just oppose these 2 figures, something that we will look into, but it's not something easy to do with ASCII art, but we will try our best. And if you have any comments on whether to do so, how to do so, that will be also very welcome. Then he also made some clarification comments, basically also showcasing the figure, something that we explain in the text, and also clarify the difference with another document. So this is something that is easy to do, and we will do it in 0.1. And that's the last slide. So basically, this is a very quick summary of all the comments that we received. As you saw, many comments were received. Some of them are clarifications that have been already done in the version that we are working on, but some others require input from the research group. And this is a summary of those. So basically, use cases. If you have any use case you think is relevant, please send to the mailing list. Then the question on the architecture, whether we should add a new startup or not, I think that deserves also some discussion on the mailing list. It's not something that we have to decide as authors. It's something that we have to discuss as group. And then if you believe that any link to any related SDO research group or working group is missing, please also raise that on the mailing list. And as always, any additional review, comment, input is always welcome. So I think that's all from my side. So you have any question, comments? Otherwise, please try to comment on the mailing list.
So please don't forget to state your name at the mic. Very helpful.
Yes, hi, Dan Bogdanovic. Can you please go to the architecture slide? So I agree with the transport stratum and the service stratum, but I don't really understand why do you want to have management plane and a control plane duplicated in both of them? I looked into it, and I think that you could just have the management plane up there in the service stratum, and then going down through it, to just essentially you would have a management plane in the service stratum, and the control plane in your transport stratum.
So basically your question is about having the management plane here in the transport?
Yeah.
But you have to also manage the resources that you have.
Don't understand that, but or you want to have a complete separation of the management of your transport stratum and the service stratum.
Sorry, can you repeat that?
You want to have a complete separation of so you want to have a management of a transport stratum and the management of a service stratum.
Yes, so that's basically why we have these two planes here, because we have the controller, the SDN controller, controlling the services, the service resources. You have also the same for the transport, and you need to have this management on these two.
So I'm going to because you're saying you have to do resource management, right? And I agree with that. So you on the physical side, you have a limited number of resources that you can manage, and then so when you're managing those, but you also have to take that into the consideration with the amount of the resources that are needed by the services.
Yes, and then?
So in this case, if you're just, I see that your management planes have to they have to cooperate, they have to talk to each other to know if they can, essentially instantiate the service, because you cannot instantiate the service without asking the transport stratum if there are available resources.
Yes, you need to, this is basically a client relationship, so if a service requires something from the transport, it has to actually request that to the transport stratum, and then the transport will basically provide that to the service. So I don't know if I'm missing your question, maybe we can take it on the mailing list.
Because I see also between resource planes, you have a communication, so where are you reserving your resources that you need from the lower layer?
Okay, let's discuss on the mailing list, thanks.
Just a comment from Stuart Bryant on Java. Might you not want to manage them differently? You still might want to configure the lower layer, run OAM, etc.
Can you go closer to the mic? Sorry,
Comments from Stuart Bryant on Java. First of all, might you not want to manage them differently? And secondly, to what you just said, you still might want to configure the lower layer, run OAM, etc.
Okay, point taken, thanks.
So there was, did we reach a conclusion with the original question? Because we do have time on the agenda, and this topic takes precedence over a number of other topics. So if you want to continue the discussion, we can, but if it's not clear what the question was, then we can move it to the list, but it's up to you, Carlos.
I think it's better to move it to the list.
Okay, right. Thank you. So we actually had very good support for this document. We haven't actually adopted many IDs into the SDN research group, and it seems that this is a particular interesting topic that can add value both to the research area, but also potentially across various working groups in the IETF. So definitely encourage people to review the document, continue to review the document, and help develop it into a useful piece of work. So I think now we can move into the second part of the research group discussion, which is SDN intent and policy, which is a very interesting area. It's rather complex. There are a number of initiatives, both within the IETF as well as other external organizations like the ONF and MEF and TMF. And apologies if I haven't mentioned your favorite SDO. Others are available. So I think, John, if you're ready, we've got a sort of tutorial with a state of the nation with regards to policy from policy experts. So let's try to make this discussion interactive as well. So if you're researching a particular area of SDN policy or indeed intent, and you have some questions or findings, conclusions, or part of your project maybe you'd want to sort of disseminate some of the challenges, then now is the good opportunity to do that.
So good morning all, and as you can see from the shirt, oh, the laser clip, thank you. As you can see from the shirt and the slide, I'm kind of a Monty Python fan. What we were going to talk about is we can't really get started unless we get some fundamental terminology straight, so I'm going to propose one. Motivation for policy, and then we'll talk about policy. The first policy conference I attended and spoke at was 1994, so we're not going to go through all 22 years. Don't worry, I don't want to kill you by PowerPoint, but we will talk about some major paradigms that have been well established over the years, and then we'll give a brief introduction to intent. Intent in the IETF, TMF, ONF, and MEF to be specific. And then some ongoing research, and hopefully this will be really interactive. So if you have a question, I'd encourage you to just get up to the mic during the presentation. Don't wait till the end. So policy, Morris Sloman, Professor Morris Sloman, defined it as rules that are governing the behavior of a system. I expanded that a little bit to rules that are governing the changing and or maintaining of state, to relate it more to network management. And when you see the bracket, number bracket, that's to a reference at the end of the presentation. So why do we care? Well, there's a working group in the IETF called ANIMA, which is about autonomic management. And even if you're not doing autonomics, the basic problem in management is that it's almost impossible to build a self-managing system where each and every component is itself self-manageable. And so this is the old divide and conquer, where self-management is actually an external set of capabilities and behavior that are projected onto the consumers of that system. And so one way to control all of the collaboration and messaging and other things that are required to provide self-managing capabilities is with policy. It's a fundamental building block. So there's currently a lot of fuss over how do we classify this? Do we talk about different types of domains like deontic logic or security or network management, or do we look at it from more of a programming language point of view? Imperative, declarative, different types of declarative, functional versus logic programming, etc. And I'm not sure that that really matters. The reason that this comes up is if you look at the literature, there's very different approaches that have been taken to building models and languages for security versus pretty much anything else. And then there's very different approaches by the logicians that have been taken when you try and use something like first order logic to implement policy. And we'll get into that in a little bit. So the upshot is that intent is very fuzzily defined. Even in anima right now, we don't have a crystal clear definition of what is intent, what isn't intent. And I'm not sure we really need that clear definition, and I'll talk about that later. So hopefully policy is there for a reason. The reason that I posit policy is needed is because it's the business that's driving things. And we've done a great job in the data plane, an okay job in the management plane, in the control plane. Management plane, not so much, right? And what we, in particular, we haven't done is, is this area here. How do we relate changes in the business to changes in the infrastructure? This is, and so the hypothesis of model-driven architectures is if you can abstract the key parts of the business and relate them to services and resources, now you can finally close the loop. So as business priorities or goals change, you can reconfigure the services to reflect those changes. And that's probably more important now than achieving a full autonomic system, because it provides increased business opportunities and revenues to the users of the system. So there's been traditionally 3 different types of policy. So ECA, event condition action, has very simple semantics. When an event happens, if the condition is true, then execute this set of actions. So what this means is that the policy rule is actually a container. It contains an event clause, a condition clause, an action clause, and traditionally each of those clauses can be a complex Boolean expression. So if I get a critical alarm from these edge devices, or if I see congestion in these core devices, and blah, 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 that could be an event clause. When you look at ECA, notice that rationality is compiled into the policy. Imperative policies are for those conditions that you know will occur and you have an answer to do what happens when that condition occurs. So you know the current state, you know what future state you want to go to, and the policy is just enforcing that state transition. So the problem is that with any imperative language, there's conflicts that can arise. This is a very simple one. So here we've got 2 services, gold and silver. Gold, if gold goes over 100 milliseconds, then we start need to increasing the CPU. For silver, if it's over 200 milliseconds, increase the CPU. Well, software guy, hardware problems, so sorry about that. if you look at this graph, so this is the gold area, this is the silver area, and everything else is a conflict because it's satisfied by both policies. Well, that's bad. So what people said is, let's introduce this concept of a priority. And now the priority can be used to say, if both of these policy rules here match, let's take the one with the higher priority, and life is good. So this clearly works. It doesn't explode the state space, but it only clearly works for very simple policies. Goal policies entered around 2000-ish, and were a big part of IBM's initial push into autonomic computing. And what the idea is in goals is that rationality, apologies again, rationality is generated not by the author, but by the compiler or the planner of the goal policies. So what's different here is that we're not explicitly saying, go to this particular state. What instead we're saying is, this is what we want to do, and so a set of states could possibly satisfy that goal. The set of states is some function here. So you have what you want as opposed to how to do it. This is higher level and more flexible, but nothing comes for free, so what's the price? Well, it's harder to implement, right? Easier for the user, harder for the software developers. You can still have conflicts in gold. So if you look at this, same two policies, in this area, it's only gold. So life is good, except which one is best, right? This is an AI hill climbing problem where you probably don't want to go to the very peak of the hill because you're going to fall off if anything goes wrong. Rather, you want to say something like, well, maybe this area here is perfect. Same problem in silver, same problem here, right? Everything is bad, so how do I get to a good state? And then here, you have a conflict. Both gold and silver, both gold and silver are conflicting, and so what do I do? Specifically, do I always want to prefer gold over silver? Well, maybe not, you know. Just a simple game theory will tell you which gives you the most revenue or optimizes use of resources or blah, blah, blah. And so what evolved from this is a thing called utility functions. And utility functions are just like goal policies, except that they do the optimization for you. And so again, I've got a set of possible states, but the difference is in a goal policy, the states are enumerated as good or bad. Here in the utility function, the states have some relative goodness on a scale of, let's say, 0 to 1. And so now, if you're familiar with any of the common AI optimization problems, this gives you an opportunity to start fine-tuning the optimization of cost versus resource versus whatever else you want algorithmically. And so this is a little higher, it's a little more abstract, it's more flexible, and of course, it's harder to use. It's great for mathematicians, not so great for the end user. And so this is just a picture of what a utility function would look like. And Obviously, as we climb up the hill, you're getting higher and higher utility. So could any of these three be intent? Sure, but I think the general feeling of researchers in intent is that it needs to be something different, right? Because all of these are aimed at the admin, or at least someone that knows what the network is, right? And the purpose of intent is to allow the end user to adjust their services via, let's say, a web portal, or an application developer that has no idea what a network is, cannot find the VPN object among, you know, the hundreds of lines of CLI code, and doesn't know how to program it. So that's where we're trying to focus in intent. This is a standardized policy architecture from the TMF, and it divides into a set of kind of steps that you can go through, but there's 5 of these 8 are, I think, of particular interest. So in this architecture, in the policy creation and editing part, there really isn't, it's not so much that, let me say it even simpler. So an intent policy versus an imperative policy versus a utility function, what we want to do is to not have multiple different interfaces and APIs and languages for each of them. And this is hard because they're different formulations, right? They have different structures, different usage. And so what we're doing in SUPA and in other places is to try and build a common framework of reusable objects that could be used for not just imperative, but declarative and functional and other types of policies. It's the assumption here that when you write a policy, it needs to be translated into a form that's consumable by the device, right? And so that's actually has interesting architectural implications on where or how many times you do the translation and how you and what you distribute, which I'll talk about in a minute. Just like good old-fashioned domains in a network, in policy you have what are called policy domains. And here, this is a policy domain. It can talk to other policy domains. And what is used in policy is federation, meaning that within a domain, it's free to have subdomains. Any subdomain must obey all of the policies of its parent domain. It's free to define new policies as long as they don't conflict with that parent domain. For the original IETF architecture of decision point, enforcement point needs to be expanded. So this shows one simple expansion. Here's the decision point, here's the enforcement point. But you also need to verify that the policy did what you were hoping that it would do. Why? Well, because policies, as you'll see in most autonomic architectures, are part of the closed control loop. And so if your policy went south for the winter, right, then you have a problem because your whole control loop is screwed up. And we could talk more about this later if you want. So this is another information model. It's called Sdnrg. This is circa 2007. And what you see, could you get me, you know, a sword or something? What you see here is there is a policy role, and it has 4 subclasses. ECA, goal policy, utility function policy, and then from a very good friend of mine, Professor Mark Burgess, promise theory. Promises are for autonomous agents. Then on the right-hand side, you see components of a policy. And these set of components change for each one of these types of policies. But I'm not that good a PowerPoint person, and the UML picture is huge, so I cheated and did it this way. So use your imagination. In SUPA, we did pretty much the exact same thing, but simplified it a lot. So, SUPA, you have the root of all policy here. You've got a policy rule, and right now, before Dan kills me, we're only looking at ECA policies. See, I'm being good. And here, there are components of those policy rules. So in SUPA, there's many different ways to build a clause. You can encode the entire clause in a single attribute. You can build up the clause by having multiple objects form a canonical policy expression of variable operator value. You can define a collection of things that are then processed later and fed back to the system, on and on and on. That is SUPA in its current form. I'm sure you can't read it because I can't read it, but if you trust me and blow it up later, the slides are available. The orange part, which is roughly here, is what's called the generic policy information model. These are the reusable building blocks. The green part, which is here and here, is the ECA part. The purple part was the declarative part, but we're going to excise that. Sorry, I just didn't have another picture, so don't worry. The key point here is that notice that there is not a single class in either the imperative or declarative part that is not subclassed from the generic policy information model. And that's really the value of SUPA. Build a framework that can support multiple architectures, multiple programming paradigms. So, intent. Why the big furor? A, because marketing people don't have anything else to do, and B, because policy's hard, right? I don't know how many people have used a policy system. The first one I wrote was 1995 in Cisco, but there's not 2 or 5 or 10 policies. There's hundreds of thousands of policies, right? And if intent is easy to use, there's going to be lots of intent statements / rules / policies. And furthermore, remember what I said in the beginning, that what we want to do is move up the stack, right? The star CIE, whether it's a CCIE, a JCIE, or whatever, probably isn't the target for intent. They're quite happy with Yang or CLI or whatever system they've got. The end user doesn't have a clue, and most application developers are somewhere in the middle. So what we want to do is raise the abstraction layer. And if we can help operators do things more powerfully. So a simple example, make sure that CPU utility is less than 70%. That was one line, right? When you expand that out, that could affect hundreds or thousands of CPU devices in hundreds of VMs. You don't want to do something like that using imperative programming. At least I don't. So you set the Wayback Machine about 16 years ago. There's this thing called the policy continuum. And what's important is not how many levels it has. Who cares? What's important is that it says that there's some high-level policy at the top, which non-technical people will use. There's some lower-level implementation that the device consumes, that the device uses, and they're joined together. So if you go into the NOC and say, John gets gold service, they'll laugh at you. Who's John? What's gold service? But if you go into the business and start talking about Yang or CLI, they'll laugh harder. So neither one disappears, right? Both have to live in concert, and I think that's the single biggest thing that policy has gotten wrong. There's no way to connect the business to the network, and that's what we're trying to do. These questions are a summarization of a long set of emails from Anima. I want to emphasize that they're my opinions, and Joel Halpern, who helped review this, and thank you, Joel, wherever you are, assuming you're here. I think he probably agrees with almost all of them. But again, they haven't been stamped as done in Anima. So who writes intent? Human. What does intent look like? Now, in my opinion, it's a restricted natural language. We can talk about that later. Other people are saying, well, it's some type of algorithmic thing. So I wrote the language spec and helped on the compiler for OpenStack Congress. It's an extended version of Datalog. I'm quite happy with it. I'm a Prolog guy. I don't know any CCIEs that know how to use it. So again, this is where the policy continuum comes in. It's not just doing the policy, it's putting it into a form that the actors that consume it are comfortable with. We have to use their terminology, not shove a language down people's throat. That never works. Blah, 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 must be translated. How is it used? Well, if I've got multiple languages, the probability of having this thing work is pretty close to zero. It's negative if I use multiple natural languages. It's not going to happen. So we need to standardize some type of translation mechanism, and that's why models are important, right? If we can define models, ontologies are fine too, if you'd like, then we can define common concepts that the system can use to understand the structure of a role. Is intent large? Nah, it should be pretty small, but it's going to affect a large number of devices if it's written well. How many intents? Well, how easy is it to use, right? And then there's some discussion about whether we should combine all intent into a single file. Joel and I think that that's potentially very dangerous because policies interact with each other. Policy components interact with each other. So there was a long yet painful discussion in the ONF over an example, Bob wants to take a taxi to an airport. So what isn't intent? Well, if Bob specifies that Fred has to be the taxi driver, and by the way, you have to take this route to the taxi, and by the way, I want a C330, and you know, on and on and on. That's clearly not intent. That's very prescriptive. So, but is airport a target? Well, of course it is. In my other example, right, optimize energy efficiency or optimize CPU utilization, the targets are implied. And so in general, for intent, it's not deontic. You don't necessarily have to specify the subject and target. If there's enough context in the intent, then those should be able to be figured out. Can intent be updated by devices? Well, once it's translated, sure, they could, but the probability of us having a completely autonomic device in my lifetime, I think, is in the single digits at best. I think that what we really want to do here is feed the results back up to a higher level management entity and let the management entity do the work and coordinate the intent. A lot of people think that the devices themselves have to process intent. I don't think it's scalable. Context. So this is something, oh, sorry, please.
Hi, John. This is Dan Drutza. I want to ask you a question more related to, you keep saying that intent comes down from the business down to the technology. I feel like we need to be cognizant of the fact that there are limitations in the technology layer that you have to give up. So your example with the CPU, the fact that, you know, I can detect CPU utilization is a it's a constraint, I would say, and I can express my intent based on what is possible to be passed as a policy. So I just want to make sure that we're not kind of going top down. You have to understand bottom up what is possible before you can express your intent. So I need to know that the airport exists before I can actually say I need to go to the airport, or that is open, or whatever example to extend. Thanks.
Hi, Dan. Absolutely agree. The part that I skipped over, but I can squeeze in at the end, is that the first thing that happens before you can write intent is that there's a negotiation. In autonomic systems, the autonomic nodes, or in animas we say autonomic functions that are supported by one or more nodes, advertise their capabilities. I can do routing, I can do a VPN, I can take you to the airport, right? Otherwise, there's nothing to write intent about, as you said. And what I've done in the systems that I've built is, in addition to that, I've advertised constraints. And so that's where you get to the, well, I want to do energy conservation in the edge. I certainly don't want to do it in the core, or my traffic will stop. Right, so, heard. Bert.
Bert Weijner, the second bullet there, can intent be updated by devices? I think you mean, and when you were talking about it, that's what I understood as well, is can intent update devices, the status of devices? A device, or did you mean to say?
I meant, can a device update intent? So
that, but intent is something that we humans, or maybe the management system, expresses, right? It's
absolutely
agree. It's not devices that have intent. Their intent is to go to sleep, I guess, right?
We are violently agreeing, but there were a lot of people that said, well, I'm going to have an intent processing card in my router, and it can generate intent, and it can process intent.
It can process, I guess, and it would generate like maybe configuration change or something like that. But it will not generate, like, if I say I want to get from this hotel to the airport, the taxi driver is not going to say, like, I'm going to change your intent. Well, he may overwrite my intent.
Well, I mean, unless you're writing a router, then I agree. You know, I don't see how the router could do it. But I put this in just because a lot of people not just in the IETF, but in other SDOs, said, well, why can't the device generate intent? And I'm hoping that we as the Sdnrg can agree that's a really bad idea.
Okay, good. We're in agreement. Thank you.
Cool. And thanks for the questions. Context. So this is something that all the SDOs that I know of agree on, but the bad news is they agree not to have it. I think that's really bad. So the great late Mark Weiser from Xerox PARC, COM technology, right? What other people call ubiquitous computing. This is all about having an intelligent network that can adapt to change. So what this is saying is that if the system is changing, if my business goals are changing, if the customer profiles and services they're running are changing, if there's congestion or a DDoS attack in the network, you probably have to change the policies that are in your working set. How do you do that without context? It doesn't exist in any standard I know of, even the TMF work that I've done so much. I hope that we fix that. Identify intent. There's a tuple up there, domain, role, and context. So for a domain, we could use roles to abstract the different responsibilities that an intent applies, and then apply context to those two things to adapt. Are there types of intent? Well, policy continuum. To me, it doesn't, saying it's in the business layer, that doesn't really say anything, right? One company might want to differentiate between product managers and, I'm not a business guy, SLA writers, right? And if they need to do that for their architecture, God bless them, let them do it, right? So the number of levels doesn't matter in the continuum, it's the abstraction.
So, John, sorry to interject. You're 2/3 of the way through your time and halfway through your slides. So don't panic just yet, but.
I already did, but okay. So you get the idea. Panicking. So this is
John?
a really key point.
John?
Oh, sorry, Sheng.
Can I go back last slides?
Could you state your name as well? Sorry.
Yeah, I'm not going to comment on any technical point here. Sheng, Huawei Anima Chair. So I have two comments. One is, Anima is not chartered to do intent work yet, but we do realize how intent work is important for autonomic networks. So, continue to discuss that in Anima, and we are probably, take that work in our next charter. Second, I'm not sure, the intent for Anima network is generic for all the other network or not, but keep that in your mind, the intent for Anima network maybe just only a subset for broader generic intent.
Yeah, I said that these are discussions on the Anima list, but they're not opinions of Anima. That's what the note says here. So if policy is used as part of the control loop, then policy is not an atomic blob. And in fact, in the architecture that you'll see in a little bit, policy applies to multiple parts of the control loop. So inside the IETF, there's a number of working groups where policy could use data emitted by those working groups, as in Alto or I2RS. It could possibly help some working groups build policies to control their functions like L3SM or I2NSF. And again, Declarative policy is not currently in scope for SUPA, so SUPA is not going to work on declarative policy, but perhaps in the meantime, if we're all very nice to our chairs, we could work on it in Sdnrg. Outside the IETF, well, you have a lot of things, right? You've got VNF, sorry, Barrett.
Yeah,
You appeared.
sorry for interrupting. Bert Wijn again. So you say Sdnrg is a good place to discuss it, but I think what we should be careful about in that case is that I think declarative policy or policy in general is something that does not only apply to an SDN environment, but it could apply to other environments as well. So be careful not to focus or to define or specify stuff that is only available or applicable to SDN, right? That's only
Absolutely.
one area where we can use it.
Yeah, absolutely, good point.
Tim China's JavaScript. Could you move the cursor from where it says the page number? It's a point for the chairs. Could you move the cursor from where it says page number? Because I can't, thank you, but I'm doing the numbers. There's a question from Laurent Chiavaglia. The initial point of discussion was if an ASA could issue or update an intent.
Sorry.
Oh, sorry, Tim, can you repeat the question?
It was from Lawrence Chiavaglia. The initial point of discussion was if an ASA could issue or update an intent.
Can
I'm
anyone
not sure of
pass
the
that?
context, but that's what I'm relaying from Jabba. If you can hear us, Lawrence, if you want to add anything else to that.
Sorry, there's too much echo and I can't hear. Can I read it?
Could you state the question as well?
Yeah. Apologies to Tim, I'm old and I've got sinusitis. It was actually from Laurent Savalia in the Anima working group, saying the original point was that the AESAs, the autonomic service agents, could push update intent. And he's absolutely right. That was the Anima discussion. The node discussion actually came from the TMF and the ONF, so apologies, Laurent. So we did that. Outside the IETF, well, you've got NFV defining VNFs, but these aren't user consumable things, right? You have the ONF working on intent. They've got version 5 of a white paper about to come out, but it's not concrete. It's still just trying to define what intent is and how you do it. The MEF and TMF are thinking about intent. They don't have an active working group formalizing it. MEF is going bottom up, but they have a good orchestrator definition that intent would go into. The TMF is going top down, but they have a good policy model. So if we could actually get those two to talk, we might move forward. Open source, there's a couple of things that I guess could qualify as intent. There's GBP in ODL, there's Congress in OpenStack. Again, for me, these are too low level, they're too close, they require network understanding. So I think we need to go up the stack. What this says is that it's not just about the data. It's about the semantics of the data, what the object means and what it's connected to. And those semantics are critical for intent. Definition of context, and this is probably more instructive. So if I have something that determines context, that determines the working set of policy rules that are applicable for that context. These policy rules then define the behavior of roles that define the behavior of managed entities. Those managed entities respond with management information that gets fed back, and we have a nice little closed control loop. What this shows is that the original was animated, but it doesn't matter if I make changes to a product, a service, a resource, or even build a whole new extension and define a new thing called an SLA and change it. All of these translate back to how policy controls a configuration. This is the strength of model-driven approaches. We're short on time, but this is the cognition cycle of Focal, which was an autonomic architecture I first built in 2005. Cognition cycle literally means how the system thinks and comes about its decisions. So you have the regular control loop here in blue. Because you have the ability to recognize previous states and discover new states, you can sometimes build shortcuts, so normal, high priority, urgent, to speed up the cognition cycle. There's a learning component that observes all of the cognition points, and that is used as I destroy the lightsaber. That's used to continually update the knowledge base. Simple, well, this looks much better in PowerPoint. So the idea here is that policy is used for behavior. So if here's your initial state, here's your final state, I might have a optimal path here, then I have policies that go in and change these two costs of these edges, and now instead of having this as an optimal path, I have that as an optimal path. This is Focal. The key thing in Focal is that here's context, loads a set of policies, policies determine the behavior of the autonomic manager, and in this control loop, each of these 5 control buttons give me an ability to alter that function of the control loop. So this is an adaptive control loop. This also differs than the IBM MAPE loop because if everything is okay, it takes the green path and ends up right where it started. If it isn't okay, then it goes somewhere else. And that's kind of how networks work. Let's skip this one. This is Focal and 2 projects from FP7. You've got business rules that could turn into some business process model. For each activity or task, you have a model and an ontology. These build a multigraph where the edges in a multigraph represent the semantic relation between model nodes, which are facts, and ontological concepts, which are the meaning or interpretation of those facts. From that, you generate a finite state machine, generate code, and repeat as necessary. This is from a proposal that Ching Wu and Joel Palpern and I did for T2TRG. This shows how policies can be used for data at rest as well as data in motion. And again, the point is not each datum, but the overall semantics of the system. And I'm probably over, or I'm close? Yeah, okay, so almost done. The biggest problem and the reason that you need modeling is what happens if you don't have perfect data? What happens if it's fragmented or lost, or it contains errors, or blah, 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 or gee, it was hacked? So there are things from the data science and AI worlds, different types of structural matching that can be used, where if you have a model of what the data should look like, and you build a model of what the data is that you received, you can compare them and figure things out. This also works for identifying new data that you don't have. This explains how to do that. I think we'll skip that. This was an actual implementation from an FP7 project in Europe, where we use a set of DSLs to config and monitor the system. The model gets translated to eCore. We wrote a couple of tools to then generate an object model that then went into Java. It's got a policy analyzer that works in this closed loop here. And conscious of time and panicking, the end goal here is that intent currently in the industry is poorly defined. I think that we really would do a great service to industry and research if we fix that. There is, intent is one type of policy, right? And so when we work on intent, we have to be cognizant of the other types of policies that work in the system. Policy management architectures are typically underspecified. There's no connection to the business. There's, little connection to behavior. There's lack of context. We have the opportunity to try and fix this. That is why policy hasn't taken off, and I think that's how we fix it. And last, there is a bits and bytes demo of the SUPA policy engine on Thursday. So thanks. Sorry if I went over and done.
No, I think that's good, John. I mean, we had some good questions. There seems to be a lot of potential for cross-fertilization amongst research groups. For instance, you mentioned sort of AI. So if we talk about machine learning, the need for some kind of heuristic to be able to monitor these actions and,
Right.
and conditions, and being able to kind of move some of that decision making into a logic engine to take some of the engineer's intuition and put it into software and be able to make those decisions far faster. That seems like a really cool kind of discussion to have in the proposed network machine learning research group. I think that's it. I think that's occurring later this week. Defining intent and some of the nice things to do that you had in your summary or your previous slide, almost feels like an insoluble problem now that I've spent 30 minutes listening to various activities that are occurring across standards organizations and sort of historic work. How would we start?
Well, I think there's a lot of good work out there, but we haven't solved the problem, right? And I think this is a difficult problem. We need more people to work on it in concert in order to solve it.
Okay. So we've got another presentation on intent. So Bert, we've got Nemo, and then if we've got some additional
Thanks.
questions at the end. Thank you, John. If we've got other questions, if you think of something now while Bert's presenting, then we can take those questions at the mic as well.
So my name is Bert Leijnen. I do some consulting work for Huawei, so some of the discussion I'm having now is based in that context. John is a very nice person, When I read his documents, however, they're often like 100 pages long and so on, and I start to worry a lot about complexity. At one time, I hope I didn't really insult you, John, that was not the intention at the time. I commented on one of his works, SID it was, I believe, where I said, this is a spaghetti bowl full of spaghetti balls. And that is the risk that we run if we want to be too generic, too nice to all sorts of developments that are going on in other standards organizations and try to unify that. Randy Bush, I was a co-area director with him for a while, always used to say, you know, if you want to standardize things, you have to standardize the intersection between different approaches and not necessarily the union. Because if you do the union, that's when you get to the spaghetti bowl of spaghetti bowls. And so, although I appreciate that we have thinkers like John who actually think about the whole big picture and all the possible implications we have when we try to do intent definitions or specify intent, I come from an area where I'm much more practical and you know, want to keep things simple. And so what I'm going to talk about now is a language to express or to define intent. And that should be a very simple language. So my slides are here now. So next, oh, I can do that myself, right? So, wow. So if you look at it in the SDN context, and we're in the SDN working research group, so that's why, you know, this picture does that. Then you see, don't tell me what to do, but tell me what I want. Like the taxi driver example that John said, actually the taxi driver is already specifying how you want to do it, because the real intent is I'm here and I want to get to the airport. And how I get there, maybe I'd like the system to decide that. Or maybe that gets decided depending on my constraints, my additional needs. Like I need to be there by 10 o'clock. So, and if it's 9 o'clock, it's already after 10 right now. So we're not going to make that anyways. So you can see that, you know, you want to tell some sort of intent engine or policy engine, whatever you call it, that there's a pointer here as well, I guess. Is that, which one is that? Oops, wrong thing. What do I do now? I did the wrong thing, I'm sorry. Yeah, I wanted to see that, I wanted to check the... But there was a pointer in here, right?
There is, yeah.
So which one is that? Red? Oh, this one.
Okay.
Okay, so you tell what you want, and there may be various applications that can actually do that. Probably they provide you a GUI or a user interface through which you can specify that intent, and that gets translated by the intent engine to either, you know, send instructions to the SDN controller, or, you know, sometimes that could also be directly to devices and so on. And depending on the various technologies that are involved, which you don't necessarily need to know at the intent specification level, at the what do I want level. So that's kind of the context in which this does. So now we have in the ONF, people from Huawei and other organizations have done intent language, the NEMO language, and it has quite a lot of commands still. It's supposedly simple, but some idea that we had, and we presented in a BOF, like I think it was 2 IETFs ago in a bar BOF, was like, we want to reduce the number of commands that a user, a person who wants to configure or express his intent needs to specify. So here are a number of primitives that exist. And so you can see there's quite a few still there. You have like 3 primitive groups, 15 statements. However, in NEMO, I believe they had something like, in the ONF, NEMO, they had something like 60 or so commands. And if you actually look at it, then a very small percentage is basically covering 80% or more of your needs. And so if you want to keep things simple, you have to question, to ask you the question to yourself, do we want to cater for everything, or do we want to cater for 80, 90% of the situations? And I think, at least as a start, that might be a good thing. So these are the type of commands that we have. Where's this red button? Yeah, here, sounds good. So there's a model definition in which you have a node, a link, and you can define an action. You have entities, which has like a node, a link, a flow, and so on. There is a behavioral model, like you can query, you can define a policy, you can define notifications. And so if you look at an example, this is pretty simple, I would say. Now, of course, the example is also simple, but that's to get the idea across of how can we keep this as simple as we can, and yet cover most of the situations where you want to express your intent. So, for example, you want to specify that you have a branch office and you have headquarters, and you want a virtual link between those, right? Or you want the connection between those. So you define that you have a node that you call branch, that's just the name that you use. You have a node that's called headquarter. You define a link as a tunnel, and you say that that tunnel has as end nodes the branch and the headquarter, so the ones that you defined there. Then your policy is that you want to apply that to the tunnel. That's the name of the policy. So you apply it to the tunnel that you defined here. And you have a condition that between 8 a.m. and 6 p.m., you want to give it a bandwidth of 10 gigabits. At night, you want to apply to the tunnel a different thing. So the condition is at night, so that's from 0 a.m. till 8 a.m. And from 6 p.m. till midnight. So then you want to give only 1 gigabit, a gigabit. And you can define those conditions here. And that's how you express the whole thing. So that in my view, looks pretty simple. And when we did our BARBOF, the idea was that we would like to at least discuss, maybe even form a working group or so, to try and define this minimum set of intent language, keywords, parameters, and so on, by which we can cover most of what, I would say our community needs, what the internet community needs. And not necessarily worry too much about all the other different standards organizations, whether they are going top down or bottom up or what have you. They're welcome to participate here, but I mean, we need a place where we can actually define this for our needs. This is another example. I can walk it over, but you have the public internet. Oops. Yeah, the public internet. You have your demilitarized zone and the protected zone, and so you configure what you want to do, and you say that you want to use a firewall on those link types, and so on. So this is a pretty simple set of commands that you could use. The other thing could be that you use plain English. Now that gets much more fuzzy, and then your engine that needs to translate that into configuration or dynamic configuration is going to get much more complex. In fact, the engine underneath this is probably going to be pretty complex already, right? Because you have all sorts of devices, all sorts of protocols, and so underneath it in order to implement this, to actually effectuate this intent. So this would be the sort of it says architecture, but this is the model as to how that works. So we have the intent description language that I just showed some examples of. It builds on intent data models. Some of them still have to be done. Others could be done in different working groups or research groups, and even other SDOs if they like. If another SDO focuses, for example, on some optical technology or on Wi-Fi technology, they can define a data model, and many of them are already using Yang these days to actually define a data model in that language. So we can use those data models and try to configure them according to the intent that we have described with the language. The question is, do we need information models, yes or no? If we were to decide that it's always going to be Yang, then maybe we don't even need an abstract or a generic information model. The problem with the generic information model, and I understand where we come from, people might want to do this with management information base. They may, in the older days, they wanted to use Corba. Some people may want to use CLI and what have you. But if we decide that in the future we want to go and work with Yang data models, then do we really need an information model that allows us to later on replace Yang with something else, or have even concurrent data models, one in Yang, one in a management information base, one in, you name it. Anyways, that was a little bit of an aside. So what happens is that the Yang data models that we populate with based on the intent, that all happens in the intent engine, policy engine, or whatever we're going to call it. This is what has currently been implemented by a few companies, and actually I believe it has been demoed as well. And then from that, you send down that configuration to your network devices. So this piece here is probably pretty complex. This piece, mapping your intent into data models may also be kind of complex. And I think John mentioned in his presentation, like if you get to business people with like a Yang language or something, they laugh at you, right? So they want a much simpler language. Now, whether intent is that language or not, that's one of the things that I think is the question that we need to ask ourselves and consider. But the idea is that we get a very simple language there. And I think that's my story. Thank you. Questions? John, for sure.
So thanks, Barrett. If you could go back to slide 6.
This one?
So as far as I understand the language, you have 3 objects, node, link, and flow, and you have a qualifier type, but there's no standardization or hierarchy that's proposed to build those. So a subset of a node could be an Ethernet port, or it could be a network. And so that kind of blows up my head. And I don't understand how you can build a Yang model from that.
No. The Yang model has to be defined as well. And the intent that you express has to be mapped into the existing Yang data models. Now, hopefully, people, when they learn about this, they will specify the Yang data model such that it is easier. But I mean, you can have a Yang data model where, on a link or on a port, you can specify, how much bandwidth you want to do, what kind of filtering you want to do. And so if you specify in the intent language, I want like 1 gigabit, then there's probably in the data model some, lose the word now, some attributes that will actually allow you to say, this port can only do 10 gigabit, right? Or maybe if it's an MPLS thing, you can say, okay, configure an MPLS path that has 10 gigabit. Or maybe if it's, something else, you can specify what to use. Now, if somebody says it needs to be able to do 100 gigabit, then of course you should not use 10 gig Ethernet ports. So you will find a data model, a Yang data model, that specifies like, okay, you can query or you can set the speed of particular ports, right? So and that all needs to be done. So the data model needs to be there to allow us to translate that intent into setting the proper attributes in the data models.
So I think what you're saying is you start with Yang and you build intent from Yang, as opposed to start with intent and then translate to Yang.
Actually, the people who do the intent should not have to know about the data models, right? That's something that the people who develop the, make sure that I press, who develop the policy or intent engine, they need to know what the data models look like. They need to know how they translate that intent into configuring the proper attributes in the data model.
I guess I'm missing that.
I'm not saying this is an easy thing to do, and things have to be, synchronized, but the difficulty will be in this space and finding, how the language, finding the proper data models, and how you can set the proper attributes based on the intent that's being expressed. So what we're trying to do is we're trying to abstract that all. That's what SUPA is all about, right? What in policy is all about. To abstract that away from the business user or maybe your customer when he says, hey, ISP. I want the connection between my branch and my head offices, my headquarters. And I want it to be 10 gigabit at night and 1 gigabyte bit during the day, or the other way around, whatever it was, right? That's what your customer wants to specify, your business person wants to specify. They don't know what a Yang data model is. And when you get that intent specification, the engine has to figure out, okay, if I want to set up a connection or a link between two endpoints, I need these Yang data models, and I need, based on the input from the intent language, like a 10 gigabit, I need to configure this attribute in this and this Yang data model. Yang module, I guess, I would say. Am I getting clearer or not? You look puzzled still.
You're getting clearer, I just don't know how to do that. I mean, I think that the purpose of the language and the model is to make the generation of Yang easier, and I don't see how they connect, but I don't want to take up any more time.
So this is another discussion that's taking place. So when we want a policy language, or whether it's an intent language or whatever, we want that to be easy for the end users. And if it gets more difficult for the people who actually write the data models, or people who actually implement the data models, that should be of a lower priority than the people who actually have to specify what their intent is, right? We should make it easy for our customers, for our users, and that it then becomes a little bit more difficult for us is something I guess we have to accept. If you think back at the SNMP management information base, it was difficult specifically for the readers, and it was also a little bit difficult for the writers, but at some point, they got used to it. But there are many, many more readers, like even if you have the intent definitions, if you have scripts that people have defined, there are many, many more readers, I mean people who read the definitions, than people who actually have to understand the implementation details to translate it into a Yang data model, or to do whatever you need to do in that policy engine.
Sorry, Steve Wright. If you go back to that figure, I'm not sure if I'm channeling the same question from John or not. I'm trying to understand those two arrows flowing, one from the information model into Yang and the other from the data model up to the intent description language. And I don't think they're showing the same things flowing.
No. So we are still, at least in SUPA, I think we're still thinking about having an information model. And based on that information model, you will have to define, people who define Yang data models that can be used by the policy or intent engines and so on, intent language, they will have to derive that from the, some of the parameters will have to be derived from the information model. Now, at device-specific data models, which we will also need in this context, in many cases, there is no information model. That's okay. If they decided not to do that, that's fine. The information model we're doing in SUPA, the idea there is that, you get a generalized sort of English-like or UML-like structure of how you model information for your policies. That's something that translates into a data model that you can actually, with an information model, it's difficult to implement from an information model, right? You need a language to do the data modeling. And so from the information model, supposedly you can use Yang, and I think I already said, you could use a MIB module, or you could use All Day Speak Corba, or you could use something else, maybe something new that comes up in the future. So my pointer. So this has nothing to do with the intent language so much, right? It is that when you have data models and you have an intent information model like a generic one that we are trying to, or a policy information model that we are trying to define in SUPA at the moment, then there will be some data models that have derived from that. The intent description language will use Yang data, well actually the implementation, the engine here, will use Yang data models to translate, so that goes as input to here, But if you were to say, for example, that you wanted let's say a terabit link, and there's a data model that does not allow you to specify a terabit link, then that's impossible, right? So there is some interaction there. Again, it looks like the user needs to know about that, but he doesn't. Actually, we need to know within the engine here whether we can do that or not.
But couldn't you equally translate from your information model to user intent?
I don't know, maybe you could. Maybe you could, if the only way to configure, if it were just for intent, maybe you could. But once you get to the devices and the network elements, you know, there are lots of data models there that are not part of the information model that we have. So you have to do something there, right?
Just in the interest of time, sorry to interrupt you, can we try to restrict this to a single request and response of the questions now?
Okay, sounds good.
Ali Karimi, you mentioned the data model. Are you talking about characteristic of the cargo?
Am I thinking of what?
Characteristic of your cargo, the end user's data.
Characteristic of the port in the
The
data model?
cargo, which is the data content.
The data model depends what it's written for, right? It's
Oh, no.
I'm not
You
understanding your
jumping
question.
from, you putting question to the audience, you presenting something to the audience. Is it the data model is the characteristic of your data or cargo of end users transporting from point A to B? Yes or no?
Yes. And
Okay,
the reason
then
for,
if that's the case, what you should do over here, because a lot of people, they're getting confused, is putting type of the data model, SP1, SP2. These are if somebody wants to go to the storage and grab information, you have to go in to put the characteristic of every model to your presentation. Then after that, you can go back to the description of the language and put it on your model. How much bandwidth does it take? Because these days, bandwidth, 1 gigabits, 10 gigabits doesn't mean anything. Depends on your characteristic of your data. Then it would assign the type of the bandwidth it needs. And users cannot do that. If you put in the characteristic of data in your model, then you should put it the type of model, and every model, how much bandwidth does it need. As a consultant, I'm telling you to another
No,
consultant who's worked
no, that's
35 years on this field.
that's fine. Can I still answer, or do you want yes or no question? So I don't know. We can chat
Well,
offline.
that's the question is that because a lot of people, they're getting confused on this. If you're coming in and give a presentation to the people, you should define what is your data model. You should define the types, different types of the data model. But you're telling everybody, I don't know, put it this and that. No.
So
Put the type
so
of the
I am not.
characteristic on your presentation. Then everybody understand. Then I agree or disagree. That's all.
Thank you.
Hi, this is a Jabber question from about 8 minutes ago, so I don't think it's been answered. From Guy Meador, it appears that the IDL you describe is more of a verbal, high-level design language rather than a policy expression language. Would you please comment on this?
I think I have the same. As a matter of fact, I have a lot of difficulty understanding most questions. Can I read it also?
Okay.
So the question is that the IDL, the intent definition language I presented, looks more like a high-level design language than a language to express intent. I don't know, that may be your perception. Maybe it's even we have to design the language still. I mean, I have given you some examples, and I know that some companies have implemented some of this material. The work, if people agree that this would be a good approach, the work we need to do, either in this research group or in some other place in IETF, I would hope, is to actually look at the commands that are available today, decide whether that's sufficient, decide which ones are superfluous and we don't need necessarily, and I would say try to standardize that. Because if you can use that language, if it's standardized and you can use it to talk to any SDN controller, whether it comes from Cisco, Huawei, Juniper, you name them, that would be great for the customers, wouldn't it? Hope that answers the question. I think we're done.
Wonderful. Thank you, Bert. Yeah, I think we've got a lot to discuss. I mean, this is a hugely complex area with lots of potential solutions.
That's right. It's far from done. There's a lot of work that needs to be done, and we need to sit together and get things going.
Thank you. So where are the blue sheets currently? We have a blue sheet. Has anyone not signed the blue sheet yet? Okay, great. Okay, Marcelo.
Hi, good morning. My name is Marcelo Santos. I am a PhD candidate at the Federal University of Pernambuco. It's a pleasure to be here, and it's a pleasure to contribute to SDN Research Group. Today, I will talk about third cost-effective SDN controller solution. So the agenda for today is talk about the SDN controller placement problem, introduce other SDN placement problems, present a model applied to a controller placement problem, and we have some concluding remarks and future works. So first of all, it's necessary to define what is SDN placement problem. In a nutshell, we need to answer three questions. How many controllers are required to cover a network? Where to place them? And what is the controller domain? We can see in the left side, for instance, a network without an SDN controller. In the right side, we have three SDN controllers in a specific place and with a specific domain. And its problem, it's not an easy problem to solve because it's considered an NP-hard problem in the literature. So in this context, are there old SDN placement problems to be analyzed? The answer is yes. We have similar placement problems in the literature, like hypervisor placement problem, where a hypervisor acts as an intermediate layer between the tenant SDN controllers and their respective virtual SDN network. And we have also another placement problem called role placement problem, where a role placement solution defines which roles must be deployed in the network and where. So what is the objective of our model? We will talk about SDN placement problem, but the main question is, what is the cost to migrate to a SDN approach? So our objective is to minimize the deployment cost while considering several constraints and investigate features of real networks backbone topologies that affect the SDN controller deployment cost. So in order to achieve our objective, that is minimize the controller placement cost, we need to calculate the number of controllers and their respective position, assign a set of switch to a SDN controller, and estimate the capacity of each SDN controllers. And of course, it will imply in a specific cost. And when I mean cost, it's a difficult question to answer because cost involves a lot of things like specific hardware, like we have a lot of vendors like HP, IBM, Juniper, and so on. And we have different softwares like Floodlight, Pox, Knox, and so on. And it will impact in the performance of our SDN controller. So we also considered some constraints like flow setup time, the delay between SDN controllers, and each SDN controller capacity. when I say about capacity, I mean the number of flows that SDN controller can handle. So here we have a simplification of our solution. So we have as input a topology composed by links and nodes and delay, and we have some parameters. And after that, we have we processed the topology and the parameters through linear programming. We developed the model and we used a solver called Cplex, and the output is a completely solution for the SDN controller placement problem. The methodology used was based, the input in this case, we used the topology zoo that has more than 200 networks, and these networks are real networks. And here we have our evaluation scenario where we considered here the control between switches and the controllers with 8 levels. The topology, we considered 112 topologies from topology zoo because we considered only the topology that has a classification as backbone network. And the controller capacity, here we have a number that represent the millions of flows that a controller can handle. Here, 1 million, 2 millions, or 4 millions. And of course, we have a cost related to each type of controller. In this case, we estimated the cost as $10,000, $15,000, and $20,000. And we also considered that each switch in our network generated 7,000 overflows, and we have a fixed constraint that is 200 milliseconds between any controller. So here we have a simplification of our model. We can discuss details of the model face-to-face or by email. And we have switches from 1 to J and K types of controllers. Here are our 2 main decision variables. And the first one represents if a controller of tape K is deployed at J. In this case, it's a binary variable. And here, Yij represents if a switch I is controlled by a controller J. So we have also another notation that represents the cost of SDN control of type K. Here we have our here we have our objective function. That means we want to try minimize the cost to deploy several SDN controllers over network. And this constraint represents that we can put just one type of controller in a specific place. Here, the important part of presentation are the results. So like I said before, what is the cost to migrate from a traditional network to SDN approach? Here we have the average number of controllers and the deployment cost in dollars. And here the delay constraints between switching the controller from 20 milliseconds until 200 milliseconds. What you can see here is a bar, and each bar represents the average, like I said before, of cost and the number of controllers here. So the number of controllers, the number of controllers are, in this case, when we have a hard constraint that is 25 milliseconds between switching the controllers, the number of controllers are around 4. But we have a fast decrease when we change the constraint for more than 50 milliseconds. And the cost fallen the number of controllers, and we focus on 2 specific bars that is when we have 50 milliseconds and 200 milliseconds to show that there is no correlation between the average delay topology and the cost of the controllers. We can see here in the left side, the correlation is very weak, around 0.4, and here almost 0. What is important to note here is there is no correlation between the average delay topology and curse. But on the other hand, what we found is a strong correlation between the topology size and the curse to deploy the controllers of the network. So, in the conclusion, we talked about SDN controller placement problem. We proposed a model based on linear programming. The result shows that 2 controllers are enough to cover backbone network. And we found no correlation between the average topology delay and the placement cost. And the delay constraint from a switch to a controller affect the correlation between the topology size and cost.
I think.
Here. So, as future work, we have the intention to investigate the placement techniques applied to SDN placement problem, and we also consider it important to work in a draft to clarify the overview of SDN placement problem, considering different type of problems like SDN controller placement problem, SDN hypervisor placement problem, and SDN world placement problem. So thank you for your attention and questions.
Thank you, Marcelo. So the rationale for the switch to controller relationship, was that sort of because it was a packet-in type function where you're doing reactive flow setup based on sort of incoming traffic? Yeah. What was there some rationale between the monitoring the latency from the switch to the controller? So that to me feels like packet-in type function with OpenFlow where you're receiving traffic that you have no specific rule for. So you're asking the controller to say, hey, what do I do with the traffic? Because obviously maybe in a proactive network or something with a control plane and you're using a controller, you're going to be setting up a number of rules in advance. So the relationship and the latency or the delay propagation between the switch and the controllers may be different. The requirements change.
Yes, I agree. In this model, we have just a simplification, and in this case, we considered only the delay between the propagation delay between a switch and a controller.
Oh, can't hear you. Okay. Okay, thanks, Marcelo. So, I mean, the controller placement problem has been, I think there was some pretty cool papers back in Hot SDN, sort of like 3 or 4 years ago, actually, and we haven't seen a huge amount of research since then. So, you know, I think this is a really interesting topic and something we should continue to discuss in the RG. Thank you, Marcelo. Okay, Quinton. So can you consider that we've got about 10 minutes for the PC presentation, if that's okay? 12 is a negotiation? Yes, I will. I'll just get your presentation ready.
Good morning, everyone. My name is Quentin Zhao. I'm from Huawei Technology. Here in my presentation here, I will go over the experiment work we have done in the PCE component by using that component as the central controller for the SDN in a more or less evolutionary way instead of a revolutionary way. The thinking behind that is that in the current service provider network, we have a lot of routers, switches are deployed for many years, and also there are rich complex of services available today. And so by analysis, the requirements from the SDN and also the existing infrastructure and existing solutions, we analyze the gaps between these two, and then we see like what is the option we have by leveraging the existing infrastructure, equipment, deployment strategies, and with minimum changes and modifications to the existing infrastructure and the deployment to satisfy the new requirement from the SDNs. So this is the reason behind this work. So I think originally my presentation was scheduled around 25 minutes. Now I think Dan told me we should reduce it to around 10 or 12 minutes. So probably I will go over the slides a little bit faster, and also I will skip some of the slides here. But the flow for the presentation is this. I first like a quick go over like what is the existing solution we have from the past calculation element in the existing network. And then we see like what is the requirement from the SDN side. We can satisfy that by using this existing technology with minimum extensions or the new work. So the past calculation element is deployed or used in the existing architecture today. The main functionality is that it is used to calculate the path for the engineering tunnel. So when you have a deterministic path to be used for the engineering tunnel, and you need a component to calculate that path. And the PCE is the component being used today in the routers. So the one benefit for the PCE component is that it can, offload the CPU heavy computations, and also it can coordinate the computations across the domains. And the original purpose for the component for the PC is primarily for the past computation for the LSPs in the MPLS architecture. So let's look at this one for the simple scenario. If we have two domains illustrated here, if we want to compute a path across these two domains, how do we do it today? So the ingress router will send the request to the PCE server, and the PCE server will have the knowledge for the boundary routers, but it doesn't have the information on the destination, which is in the another domain. But the first PCE will talk to the second PCE, and the second PCE will answer back what is the best path from the domain routers to the destination routers in the second domain. And the second PC will answer back to the first PC, and the first PC will answer it back to the ingress. So by doing this loop, we have the inter-domain LSP path computed. Then we use the RSVP signaling protocol to set up the inter-domain engineering tunnel. So this is the PSAP protocols procedures. More or less is the server and client-based model. So the client will send the request to the server, and the server will calculate the path. In most cases, it's intra-domain path, but in some cases, for the complex service provider network, it will have the inter-domain LSP path.
Quinton, sorry, we're 6 minutes into the presentation.
Okay. So I may go faster. So for the PC deployment options, there are multiple deployment options. You can do the server and the server client, and so this is the real deployment scenarios in the existing network. So the PC is evolving for the past few years toward the SDN concept. Basically, we are doing step by step, and it is evolving gradually to the SDN architecture, or to satisfy the requirement from the SDN requirement. So the one thing is that there is a hierarchical PCE architecture available to deal with the large number of routes with the inter-domain deployment scenarios. So we have the hierarchical PCE architecture available. Then next one, we have the stateful PCE, which, like, you know, before all of the LSP states are on the ingress router or on the forwarding engine side, but now we move the states back or up to the PCE server side. Then not only that, we have the state also, we go to the next step, we have the active PCE. Basically, from the passive PC, we are going to the active PCE. So when we say the PCE is active, is more or less it takes some, like, you know, the control functionality from the routers into the controller. And now we can initiate the LSP remotely. So instead of from the ingress router itself. So the new work we have now, we have in the Spring working group, we have in the SFC area, we also have in the wireless area, but more or less the focus for us is on the PCE area. So I'll skip this one. So there are gaps between the existing technology from the PCE solution and also the new SDN architectures. But by analyzing all of this one, we found out, like, you know, PCE is a good match to be functioning as the central controller in the existing deployment network. So the main point is that we can use OpenFlow for some operation scenarios, but for the existing service provider networks, there are some, like, you know, limitations. And there is the second solution is for the existing MPLS or IP tunnel technologies, the complexity is the issue for the service providers. And the third one, we have the IGP extension-based SR solution. It can provide, like, the P2P service, but it doesn't provide the full set of the MPLS services available today. So by this, we are going to the PCE-CC solution direction. Basically, we use the PCE as the central controller component for the SDN. And by extending the PSAP protocol to function as the southbound API, so the server PCE is talking to each node in the network. And primarily it is for the label resources and the forwarding entries. All of this information will be downloaded to the network node directly instead of download all of that information into the ingress. Then ingress will use the RSVP signaling protocol to signal to all of the engineering part. So in the user case draft, we document all of the user cases we can solve in the this solution. And I will basically I mentioned like the basic scenarios we are providing now is the basic TLSP, which is hub by hub switching LSP tunnels. We can provide the P2MP LSP, and also we can provide the SRT LSP. So I will skip the details for the LSP setup procedures here. So one use case is the for the SDN migrations. So so in this picture, you can see in the service provider networks, is more or less the possible scenario is that they are only upgrading a certain part of their routers to be central controlled. Instead of one day, they upgrading all of their routers. So for a large network, probably they will update maybe only a certain area of the routers to be central controlled. So in this picture, you can see from the node 1 to node 2, they will be controlled by the RSPT or the distributed system as it is today. They will not touch those portions of the network. And from the node 2 to the sender node X, a bunch of central control X nodes, those network nodes will be replaced or upgraded to be central controlled. And from the node 4 to node 5, those are the nodes are controlled by the traditional distributed system, signaling system. Now, the good point is here. The PCE CC or a PCE component is talking to the existing node in the network naturally because it is designed by doing that way and also is deployed in the network. But then by leveraging the southbound API to the central controlled node between the PCCC and the node X, so we achieve the goal to control all of those nodes by the centralized system. So these are the two drafts related to this work. One is the in TEAS working group. We document all of the user cases. And the second draft is the draft we document the southbound API primarily today. And so we have some initial implementations to verify this one. And we are doing more experiment to see the the scalability, performance, and to find out the more like application scenarios we can satisfy by using this solution. I think.
Thank you, Quinton. So apologies that we kind of had to rush you through the presentation, but I think what would be really interesting looking at some of those slides is to understand a little bit more about when you talk about scalability or performance, is to look at this in the context of, we have control planes for a reason. PCE talks to a control plane. It can set up an LSP, packet or optical. What are the benefits of using the PCE to talk to each forwarding element individually? Is it a performance scaling? How do you handle things like availability and consistency of resource information within the network? It'd be nice to understand, what the motivations are for the architecture. But I'll take these questions to the list, and maybe we can discuss it further.
Okay, thank you.
Catalin. Yes, yeah, 8.5, approximately. I'll throw something at you.
Okay, good morning. Take it like this. My name is Katalin Meirosho. I'm with Ericsson Research in Stockholm, Sweden. And I will talk about how can we see what gains we can get from using DevOps techniques in software-defined infrastructure. So what does it mean that we would use DevOps techniques in software-defined infrastructure? Well, for starters, we have a draft in NFVRG that describes a little bit of the research challenges that are associated with using DevOps ideas in telecom infrastructure. And in the draft, we define some roles for personnel and a set of technical challenges around monitoring and verification and all the CAP-related troubles. Then, as an observation, data center DevOps tools, well-known software like Ansible and Puppet and Chef and Splunk, they are reportedly being used in both research proof of concepts and production. And I've seen a couple of papers in the last year that were produced by research departments from operators talking about using these tools. So DevOps is being used. Now, I put here on these graphs some data that I found from public sources on the percentage of human errors related to IT and telecom incidents. And of course, depending who is giving the data, these numbers are quite different. I will stay a little bit more on the ENISA study. The ENISA is the European Network Security and Network and Information Security Agency. And they report every year the number of incidents that the operators in Europe are forced to report to the regulators as part of the regulatory framework. It's called Article 13 incidents, and these are incidents that that caused a significant interruption of service in European networks. So about 20-something% are due to human errors. Also from the ENISA report is they look in a little bit more details, and when it comes to the duration of incidents, we have faulty software changes and updates that are about 7,000 minutes, so quite a few hours in duration. Network overload, about 700 minutes, and policy and procedure faults, about 1,200 minutes. These are average numbers for the incidents that were reported in 2014. And how can DevOps reduce the number of human error rates? Well, a lot of DevOps, it's about automation and verification. So provisioning performed by the controllers and orchestrator driven by scripted templates would reduce some of the human errors. Verification, as in checking compliance with policies and doing it before and after deployment, would help as well. In terms of reducing the overload incidents in particular, we think that better observability and predicting the risk of overload network-wide by monitoring each port in the network could help. And then a lot of policy-driven automated actions would help in this respect as well. So we have a European project, and I'm contributing to that project that tries to help operator increase the velocity of service introduction. And in one of the work packages of this project, we develop a set of features that relate to observability and verification. And there's a number of open source tools in this respect that are available on the project website. Some of our results are are listed on this page. So basically, we are able to predict network congestion with very low overhead. So basically, it takes just a few megabytes to predict congestion on network ports. If we have a big data center with about 100,000 ports. We have worked on consistent network updates. We have worked on a workflow engine for debugging and troubleshooting. And we even have works related to some intents for measuring and OAM. And more important, we have a lot of work about formal verification for pre and post deployment and automated validation of services. So how much can we do we think we can save? So what is the potential for gains, especially for the three types of incidents that I mentioned earlier? So for overload, there is the dark blue line for fault policy and for the software changes. Now on the vertical line, there is the original, there is the incident duration in minutes, and here is a decreased incident lifetime in percentage depending on how much we can reduce. And how much we can reduce depends on a lot of factors. And that is very difficult to actually determine. And that's why I try to plot a range between 10 and 80% savings. For the overload, what we need to take into account is the accuracy of the prediction, the time which is gained through the prediction. So how fast, how much more in advance we're able to predict that the system will have an overload. Then whether the VNFs in the system actually implement overload protection, and what is the reaction time for scale out combined between all the orchestration systems and the controllers. When it comes to faulty software change and policies, we have to look at self-describing policies and manual modeling errors and the ratio of parameters which are covered by the verification capabilities that are deployed with the system and integrated with orchestration. There's a question.
No. The light's not on. Can you use the other mic? Sorry, in front
The
of
other
you.
mic, please.
Yeah.
Hi, Catalin. Quick question, or maybe a clarification. That steep downline is very, optimistically
Right.
presented there. But I'm wondering if the reason that decrease is so dramatic, is it because the infrastructure scales out accordingly? And once it's not that much the predictability, but the fact that you can't actually scale out in real time, where the other ones are purely software faults, which means that the thing is screwed anyway.
Yeah, absolutely. I mean, the fact that we have the capability to scale out and to scale out according to a predefined set of rules that are understood by both the operators and the developers of those functions, that's what could actually trigger that steep line of savings. The other thing is that in the 2014 report of ENISA, apparently they had an outlier as part that affected the average duration for that type of incidents. So that it's also an effect from the data that is part of that. And since I was asked to be fast, this is a conclusion. So we think that there are significant gains that are possible in terms of reducing the number and the duration of incidents. DevOps tools would help through automation, better observability, and integrated verification for the policies. but those DevOps in itself would still need defensive programming of the VNFs and infrastructure agility, like the scaling that was mentioned here, to complement the tools that are becoming available to the operators and developers. And it's very difficult to measure these gains. There is very few data available. So if you have some data and you'd like to talk to us, we'd be very interested in listening to that.
Thank you. So. Thank you, Kathleen.
Morning. And after so many interesting research on SDN, and let's get to some practical practice on SDN. And my topic is about the problem statement of SDN and NFV co-deployment in cloud data centers. And my name is Guro. I hope I can get a perfect time control. And this is the related draft is the updated version of the draft SDN problem statement of SDN and NFV. And the next related draft is a new version of the decoupling scheme of hypervisor, and which will describe detailedly in this slide. And about the introduction, the problem statements. In this draft, we describe about the problems which we'll find out in SDN and NFV co-deployment in cloud data centers. And here is the SDN and NFV use case in cloud data centers. In the use case, we can see from the up to down, there are application, orchestrator, the controller, and the forwarding devices. The changes from the last version 00 to the version to the latest version, which is noted in the red. There are the changes. Changes are virtualized platform. As we find out that when we change the virtualized platform from the KVM hypervisor to other commercial hypervisors, some problems came out. And about the next network architecture and some changes when we bring the bare metal servers, maybe some problems came out. And the next is about the extension of network. We are thinking about of the enlargement of the cloud data centers. And the next is the DCI, the data center interconnection. The connection between the traditional data centers and the SDN data centers. These are the descriptions in the updated version draft. Next, let's come to the 4 changes one by one. The first one is about the network architecture. Here is the physical topology. From the up to down, there are internet router, the core switch, the top rack switch, and the servers. Here are the changes when the bare metal server are brought in. So there are two kind of different top rack switch. One is the traditional one, which belongs to the underlay network, and the other kind is the SDN top rack, which can be regarded as the VTAP. And about the servers, now there are, besides the virtualized servers, which is deployed about the hypervisor, and another is the bare metal servers. So the problem is when we brought in the bare metal servers, we should get some changes on the top rack and the OpenStack. As we know, we can get the help from the OpenStack Ionic model, which is used to power the bare metal server and install the operating system. However, maybe the ironic model hasn't been matured because when we use the ironic model, we create the bare metal server in a flat network without the concept of network. So maybe some more work need to be done on the OpenStack neutral model and the ironic model. And the related question is about the OpenStack version. Up to now, the OpenStack version Kilo supports the ironic model, but when we change the OpenStack version, maybe some problems may come out. And the next problem is about the virtualized platform. Up to now, the KVM hybrider is well supported by the SDN, but when we change the hybrider KVM to some commercial hybriders, some problems come out. We can show an example. Here we use the VMware ESXi hybrider. We take this example only because the VMware ESXi is widely deployed in our private cloud. And the problem came out. As we know, in the KVM hybrider, the virtual switch can be the open virtual switch, while in the ESXi hybrider, the virtual switch is bonding with the hybrider. So there are two problems. One is the integration of SDN controller with different hybriders, and the second is the relationship between the open switch and the switch bonding on the hybrider. Here we give two solutions in the new draft decoupling scheme hybrider. One is substitution the virtual switch, which belongs to the SDN, which can be controlled by the SDN controller. As we know, the virtual switch, which is bonding on the hybrider, cannot be controlled by the SDN controller. So if we use another virtual switch, which can be controlled by the SDN controller, then the problem can be resolved. But there are some limitations, as we should do some development on the hybrider. So the private interface of the hybrider should be open. And the next solution is we can use a virtual machine. We can create a virtual machine as the virtual switch. Here, there is no change on the hybrider, but we should use we should create another virtual machine, which can be regarded as a virtual switch. Here, the traffic, all the traffic goes to the virtual switch should be directly moved to the virtual machine. So all traffic goes through the virtual machine, which can be the bottleneck, which can influence the performance. There are only two solutions we find out in the VMware ESXi hybrider. If you have any other maybe solutions, you can share with me. And the next question is about the extension of network. The extension network, when we faced about the cloud data center enlargement, we find out that the number can show when we create the 300 virtual machines co-built, and it takes about 25 minutes to build the flow table on the controller, which we think is quite a long time. How about 3,000 virtual machines, 30,000 virtual machines? And how about the bare metal servers if we enlarge the numbers? So we think that may be focused on. And the last one is about the data center interconnection. The SDN cloud data centers belong to different vendors. There is no trial about that, the interconnection between two different vendors. And also the traditional cloud data centers interconnected with the SDN cloud data centers. Maybe there are some other more SDN devices should be deployed on. These are 4 aspects which we are described in the updated version. And we found out these problems in our practical practice. Maybe I described it a bit quickly. If you want to find some tools, you can see my draft in the Sdn research group. And about the questions, would you like to share your practice experience? As I asked the question in my mail, in the mail list, you can reply my mail list. Would you like to participate and contribute to this work? Because we think in the practical trial, we find many problems.
So there's a question at the mic, and Sue, if you don't mind getting ready.
Okay.
Yeah, this is Loay Jalil. Are most of your problem and challenges related to OpenStack? Okay, I just make clear.
I'm sorry?
Okay. Thank you.
And about last one, and about all the problems I described in my draft, I think I should find a way to summarize in building this informational draft. So maybe you can give me some advice. And next, we can still solid comments and suggestions. So this is, I didn't leave my mail email. Maybe after that we can connect with each other. I'm sorry.
Thank you, Ron. So we're almost finished. We have a very quick request from Sue regarding BGP flow spec. Just before we have that, who has the blue sheets? Gone. Well, we've got one. Is there another blue sheet somewhere? Just have a look around you in the immediate vicinity where you're sitting. Okay. I guess that's a fun game. Find it.
Oh, no, go ahead. It goes right? Okay, this is, first of all, for those of you who don't know me, I am in this hat, the IDR chair, and IDR stands for Interdomain Routing, and IDR is BGP. And in this case, I am asking the Sdnrg research group to give us input specifically on deployments. About BGP flow spec. Now, just in case you don't know what BGP flow spec is, BGP sends around flow filter rules. Many of you talked about how you might do filtering, and these filter rules are encoded in a BGP NLRI and in a BGP extended community. The NLRI has the match filter, and the BGP extended community has the action. And BGP is considering, and this action might be modify the filter, or it might modify the packet, or it might be forwarded. BGP is now looking for input from people who are doing SDN, specifically people who are deploying operational. I was so excited to see China Mobile's presentation and several others. So we are looking for, we have approved option number 1, which is a BGP flow spec in the denial of service, or the distributed denial of service. But what we need your input from is whether it's really being deployed in networks for SDN or NFRG. We want to know if people want to put this in BGP, because BGP doesn't just put things in for good ideas, it puts it in if there's a real need for operators. So if you're an operator and you're using it, like I saw in the last slides, it would be really good to tell me that, to let me take your name down, and to spread it with the IDR group, because at this point they said, we don't think it's real yet. If it's real and you're using it, please tell me. Why do we need to have that? Because option 2 will require some changes to the flow spec. It will be changes in order to
give us an ordering to those filter rules. Where would those filter rules go? I didn't tell you that. Most people who have BGP filter rules take those filter rules, pass them around in the BGP infrastructure, and then at the place where they come to a router, they take it from the BGP data and they drop it into the actual installation. So it guards the flows. So you might have flows that might not go through the router based on this flow spec. For denial of service, that's really important to have quick distribution of blocking of traffic that's attacking you. For Sdnrg, FRG, you may want to have it in order to direct paths. So I need input. The reason we need input is there is ordering of these rules. Maybe I want to have MPLS first, and then I want to do IP, and then I want to do something else. And John, I should have said this earlier. John reminds me, these are packet filtering rules, in case I didn't say that. Questions about this call? I guess I'm standing between you and lunch, right? Okay.
That's definitely one reason. But I think we need to have, you need to bring this to the list as well, right? I mean.
Yes, I will be glad to. Thank you.
Yeah. Okay, so thank you, everybody. Apologies for eating 5 minutes into your lunch break. We did have, if time permitting, we wanted to have a discussion on sort of the format of the Sdnrg and future potential sort of research topics, which we will take to the list as well. So we will follow our own advice. So thank you very much. Enjoy the rest of the week. If you haven't signed the blue sheet, please come to the front. Can I have a pen? Yeah. Another satisfied customer.